Hi students, now we are going to discuss subtraction of vectors. Okay, we have already studied in mathematics subtraction of numbers by arithmetic methods. In the same lines, we cannot do the subtraction of vectors. Subtraction of vectors is possible either geometrically or analytically. Now, by geometrical method, how to find the subtraction of two given vectors? Okay, what are the two given vectors I have considered? Vector A and vector B. These two vectors are acting in different directions. So, there is some angle made between the two vectors. So, I will consider the two given vectors first of all. So, for that, while adding the two vectors, first what we did, we will start from that. For addition of vectors, what we did know, we will start from that. So, keeping one vector as it is, I will bring the other vector such that the tail of the second vector is made in contact with the head of the first vector without changing the angle. So, you can see here, I am shifting the second vector such that the tail of the second vector B is in contact with the head of the first vector A. So, I have shifted the vector B here. So that you can see here the angle between the two vectors. The angle between the two vectors is taken as theta. Now can you see that the two given vectors A and B are in the same order? So vector A follows vector B. Okay. So if you join the tail of A with the head of B vector, that will be equal to A plus B. That also let us represent here itself. So if I join the head of B with the tail of A, this vector will be the resultant vector and this will be equal to A vector plus B vector. So this is A vector plus B vector and this is denoted by R vector. So this is what we have studied in the addition of two vectors. Okay. Now if you want to subtract one vector from the other vector, there is no separate method called subtraction of vectors. We have to again go by the same lines of addition of vector only. How? Let us see now. I am going to represent A vector minus B vector. That is also equal to A vector added with the negative of B vector. The negative of B vector. This is the method by which we can do the subtraction of two vectors. So, my dear students, subtraction of one vector from the other vector is equal to addition of one vector with the negative of the other vector. So, here I am going to subtract B vector from A vector. So, it is represented as A vector minus B vector. So, this is also equal to the sum of the two vectors, namely A vector and the negative of B vector. Say for example, one vector, okay, say for example, this is a vector B. What is the negative? What do you mean by negative of this vector? We have to change the direction. We have to rotate the vector through 180 degree. So this is negative of the vector B. Like that. Suppose if you are given a vector B in the forward direction like this, negative of B will be what? We have to rotate the vector through 180 degree. Can you see that this is negative of the given vector? So the negative of any vector is got by rotating the given vector through 180 degree. Understand? So you see here this is vector B. Now I want to find the vector minus B. So first I will take the given vector A as it is. Okay, the given vector A is taken as it is. Okay, this is the vector A. I am not going to disturb this vector. But now vector B is to be rotated. You see here B is rotated. So this is rotated like this. Can you all see that the vector B has been rotated through 180 degree? The actual direction of B was upward like this. Now I have rotated the vector B. So that now what is the angle? What is the angle? Suppose if this angle is theta, means this remaining angle is what? 180 minus theta. So this is vector A and this is minus b vector. I have rotated b through 180 degree. So what was the earlier angle between the two given vectors a and b? That was the theta. Now what is the new angle between the vector a and the negative of vector b? It is 180 minus theta. Okay. Now also you check whether the two vectors a and minus b are in the same order. You see here, a and b are in the same order. Earlier, a and b were in the same order, but they were in the anti-clockwise direction. Now you can see that a vector and minus b vector, here also they are in the same order, but it is in the clockwise direction. That's the difference. Now I am going to join. The head of minus b and the tail of a. Okay, so I am going to join this. So when I join this, this will be equal to the resultant vector. Here the resultant vector is equal to vector a minus vector b. Understand? So this is how by geometrical method we are able to see the subtraction of two vectors. Suppose if you measure the modulus of a vector plus b vector, this will also be equal to the modulus of a vector minus b vector. So they are equal in magnitude. If you measure this vector a plus b and a minus b, they will be equal in magnitude, but they will be different or opposite in the direction. Okay, now in triangle law and parallelogram law, we have got the expression for the resultant vector. Is it not? So here if r is equal to a vector minus b vector means, then the modulus of the resultant vector, that is modulus of r vector. So this is equal to modulus of a vector minus b vector, and this is now equal to square root of a square plus b square plus 2ab into cos of the angle between a and minus b is what? 180 minus theta, is it not? So this is 180 minus theta. So inside the square root. But cos of 180 minus theta is equal to what? Minus of cos theta. Minus cos theta. So this is now equal to square root of a square plus b square plus 2ab into, this is minus cos theta. Okay, minus of cos theta inside the square root. So this is equal to square root of r. This r is equal to square root of a square plus b square minus 2ab into cos theta. Now already we have derived it in triangle law and parallelogram law. The modulus of a plus b vector we have studied. That was equal to how much? Square root of a square plus b square plus 2ab cos theta. Since it is subtraction of vector, here we are getting a minus term. Keep it in mind. Okay. Now, suppose you take the resultant vector. Okay. The resultant vector here is making an angle alpha. So, with respect to the horizontal vector, namely a. Then, earlier for sum of the two vectors we have studied one expression for tan alpha. In that we are going to substitute for negative of the vector. So this is tan alpha is equal to b sin theta. Okay, b sin theta divided by a minus b cos theta. So earlier we have studied that a plus b cos theta. Now it will come as a minus b cos theta. That's only difference. So this tan alpha will be useful in finding the direction of the resultant vector. So from this alpha is equal to tan inverse of b sin theta. Okay, b sin theta divided by a minus b cos theta. So this gives the direction of the resultant vector, that is a minus b vector. And the previous equation, this r is equal to square root of a square plus b square minus 2ab cos theta gives what? The magnitude of the resultant vector, that is the magnitude of a vector minus b vector. Okay, have you all understood? Fine.